Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Advanced Algebra 1 and 2 class. We are going to work on 8.3 Part 2 today, but just give me 1 second for these announcements. Okay, boys. So, we're going to be doing 8.3 Part 2 today. And for example 3, it says determine the function or equation for each table or situation. Okay. So what has to happen here is you have to try to figure out, okay, what am I doing to the x consistently? Because remember, a function is an equation. It works the same every single time, no matter what x value. So what am I doing to the x to get to this y? Yes, sir. You're subtracting 3 is one option. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. So y equals x minus 3. Great job, sir. For B, what am I doing to x to get to y in this case? Yes, sir. Multiplying by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Y equals 3x. Excellent, sir. Now, sometimes they're not that easy, okay? So I'm going to show you a little trick. Do you guys remember? I don't know if you guys remember, but you could find an equation here by finding the slope and then plugging that slope into the point slope form. I don't know if you guys remember that or not, but it was something that we learned. Now you could do that, but before you can do that and before I show you how to do that, you have to verify if it's a linear function or a different type of function. Because if it's a different type of function, you have to do something else to it. So I don't know if you guys remember, but you can tell what kind of a function it is by comparing the change in x over the change in y. What am I talking about? Or actually, rather, the change in y over the change in x. Sorry. So from negative 2 to negative 1, I'm sorry, to positive 1. No, negative 1. What did I do there? I added 1. From negative 1 to 0? From 0 to 1? Okay. From 1 to 2i. From 2 to 3i. From 3 to 4i. Okay. Is the change in y divided by the change in x the same for each set here? So that means that it's a linear function. So when the first change in y divided by the change in x is constant, it's a linear function. So let's say you just didn't see that you had to subtract 3 here. Get your 2 points. There's x1, y1, x2, y2. First find your slope. y2 minus y1 over x2 minus x1. That's going to be negative 1 over 1. So my slope is negative 1. Then you plug it into the point slope form. Y minus y1 equals m times x minus x1. So y, you have your x1 and y1 labeled, minus y1, that'd be plus 2, equals m times x minus x1. So y plus 2 equals negative x plus 1. Subtract 2 to both sides. And wait a second. This is not a negative. It's a positive. Come on, Mr. Morrow. Learn how to add. So y equals x minus 3. So if you don't remember that, I would suggest strongly that you go back in time to your notes, to your videos, and review what exactly it is that I did there. But the key that I wanted to show you here is how to test to see if it is linear. Okay? And this second one, how do we test to see it's linear? Let's check it out. What do I do to get from 3 to 6? And from 6 to 9? And from 9 to 12? Added 3. From 1 to 2? 2 to 3? 3 to 4? Okay. 3 divided by 1, 3 divided by 1, 3 divided by 1. Is the change in y over the change in x, is it constant? So if the first change in y over the change in x is constant, it is linear. Now, let's say that doesn't work. Then you go to your second change in y. If the second change in y over the change in x is constant, then it's quadratic. That means that x is squared. If that doesn't work, then you go to your third change in y. If your third change in y over your change in x is constant, then it's a cubic. Okay? Let me give you one example real quick. I'm going to give you whatever. Let's just make an easy one so we can continue. Let's just look at x squared plus 1. Okay? Let's make a table here right quick. -2. And let me change it up for you so you can see what's going on. Well, let's just do it easy. So, okay, when we got -2, we got 5, 2, 1, 2, and 5. Okay. From 5 to 2, what did I do? What is it? -3. From 2 to 1, what is it? From 1 to 2? From 2 to 5? Okay. From -2 to -1? -1 to 0? 0 to 1? 1 to 2? Okay. So this is my first change in y. Is my first change in y over the change in x constant here, guys? Okay, some said yes, some said no. -3 over 1 is 3. -1 over 1 is -1. Is that constant? So go to your second change in y. From -3 to -1, what did I do? Add 2. From -1 to +1, what did I do? From +1 to +3, what did I do? Now, is 2 over 1, 2 over 1, 2 over 1, is that constant? Then you know it's quadratic. Make sense? This is a very wicked, awesome trick. So I hope you really do understand it. Okay, let's go back now. Here, easy stuff. Again, this is linear equations. Gym you join costs $30 per month plus one-time fee of $250. How do I represent this in a function? Y or f of x equals 30x plus 250, where f of x represents the y, which represents the cost. Thank you. And what does the x represent? Yeah, the number of months that you go. Guys, you've got to be able to understand what it is that you're writing. If not, it's going to be very difficult. Okay, ABC cell phones charges $20 per month for unlimited usage of phone. So I could put y equals 20x or f of x. Remember, when we're talking about functions, a lot of times they like to use f of x. Remember that f of x just stands for function f with independent variable x. It's the same thing as y. So what have I told you? Okay, what does this f of x stand for? What does this y stand for? What is it? That's the cost. And what does the x stand for? The number of months. You with me here, guys? Okay, thank you. Identify the independent and dependent variables in each situation. In winter, more electricity is used when the temperature goes down and less is used when the temperature goes up. So what's my dependent and what's my independent? What depends on what here? Perfect. Electricity usage, right? So electricity usage is dependent on temperature. Perfect. Perfection. The cost of shipping a package is based on its weight. No. The dependent is not the package. The dependent is the cost of shipping. And what is the independent? The weight. The package is nothing. The package is neither independent or independent. It's the weight of the package that is independent. Okay? The faster Mike walks, the quicker he gets home. This is a good one. What's dependent? What's independent? Okay, the rate is what? Independent. Because you can choose how fast you want to walk. And then go ahead. The dependent is the time it takes to get home. Correct. Very good job, son. Well done, boys. A company charges $10 per hour to rent a jackhammer. The dependent is the cost. Very good, my brother. And then dependent is number of hours. If I rent it for 1 hour, it's $10. If I rent it for 10 hours, it's $100. Apples cost 99 cents per pound. Dependent would be the cost. And then independent would be the number of pounds, not the number of apples. The number of pounds. Okay, now, it would be the number of apples if it said apples cost, whatever, 99 cents per apple. Then it would be the number of apples. Thank you, my man. Mistakes are how we learn. Thank you. God bless you. May I continue, my brothers? Okay, now, the function rule. A function rule is an equation that represents the output value. Remember, the output value is the dependent in terms of the input value, x. You can write a function rule in function notation. Shown below are examples of function rules. Okay. Please remember that the y is the output. The fancy way to write the output in function notation is f of x. The x is the input. The x, that is the independent variable. So I could write this in function notation as f of x equals 3x plus 2. You read this as f of x or function f of x or function f with independent variable x. I need you to understand this. Now, if I ask you, find the value of f of 1, what am I replacing the x with there, guys? 1. So I literally plug in 3 times 1 plus 2. So f of 1 would equal 5. Does that make sense, gentlemen? Now, what if I told you this, guys? Let's pay attention. What if I said find the value of f of negative 2? What am I replacing x with? So this is 3 times negative 2 plus 2. So f of negative 2 would be? Now I want you to understand how to write this as an ordered pair. What's the x value here? Negative 2 is the x value, guys. What did I replace the x with? Negative 2, that's the x value. What's the y value here? Or the f of x value? Negative 4. What if for this same function, I say to you, find x when f of x equals 0. How would am I replacing the x with 0 there? No. I am replacing the f of x with 0. That means y equals 0. Good man. So that means I'm solving for x in this case. Negative 2 equals 3x divided by 3. So x would be negative 2 over 3. What would the ordered pair be here? Negative 2 over 3, comma 0. What did I just find here? The x-intercept. Very good. That's the x-intercept. When you find the x-intercept, sometimes they call that finding the 0. It's making sense, boys. Promise? Now's the time to ask. Okay? So for f of x equals negative 2x plus 5, evaluate each. I want to find f of negative 3. What am I replacing the x with? So this is negative 2 times negative 3 plus 5. So f of negative 3 equals 11. Negative 2 times negative 3 is positive 6 plus 5 is 11. What's the ordered pair? Negative 3 comma 11. Good job. F of 1/4 equals, what am I replacing the x with? 1/4. So what's negative 1/2 plus 5? So f of 1/4 equals negative 1/2. So what does that equal? 4.5 or 9/2. What is the ordered pair? 1/4, 9/2. F of 0, what am I replacing the x with? So negative 2 times 0 plus 5. So f of 0 equals 5. What's the ordered pair? 0, 5. Is that, what kind of an intercept is that? That's a y-intercept. Is that considered a 0? No. Only x-intercepts are considered zeros. Are you with me here, guys? Now comes the fun part. Now comes the fun part. And I love this type of stuff. I want to find f of x minus 1. What am I replacing the x with here, guys? So every x in the original function f, I'm going to replace it with x minus 1. So this is going to give me negative 4 times x minus 1 squared plus 1. So this is negative 4 times, please remember that x minus 1 squared is not x squared plus 1. It's x minus 1 times x minus 1. These are skills we have already learned. So this is x squared minus 2x plus 1. If you don't remember how to do that, remember it's x minus 1, and then you have to FOIL, which I'm not going to do because we're beyond that already. Okay? So we have negative 4 times x minus 1 squared, which is x squared minus 2x plus 1 plus 1. Now distribute. So I've got negative 4x squared plus 8x minus 4 plus 1. So f of x minus 1 equals negative 4x squared plus 8x minus 3. And you just leave it like that, of course. Does that make sense, boys? Promise. Okay. Now, f of x plus f of negative 2. All right. I have two different things here. I'm adding it two different functions. F of x, what am I replacing the x with? What am I replacing the x with? What am I replacing the x with? X, guys. X. Right here it's just x. Why would it be x squared? It's just x. So I have negative 4x squared plus 1, because it's f of x, it's just the function itself, plus f of negative 2. So plus negative 4 times 2 squared plus 1. Are you guys seeing this? Guys, this is the time to ask. There's no shame in asking. Yes, sir. Correct. You first wrote down the f of x, which was just negative 4x squared plus 1, plus I want f of negative 2. So I plugged in f of x, but I replaced the x with negative 2. You feel me? Thank you, my brother. So this would be negative 4x squared plus 1 plus, what's negative 2 squared? 4 times negative 4 plus 1. So that's going to be a negative 15. So that equals negative 4x squared minus 14. And if I wanted to factor out a 2, I could. You guys with me here? Okay. Remember, there's no shame in asking. It's called learning. There's no shame in asking. So f of 0, okay, what am I replacing the x with here in this one? So I've got negative 4 times 0 squared plus 1 plus, what am I replacing the x with here? So plus, I'm going to put a parenthesis, negative 4 times x plus 3 squared plus 1. Very good. So for this one, 0 squared is 0 times negative 4, so I'm left with a 1 here, plus parentheses, negative 4. Please remember this is x plus 3 times x plus 3, so that's x squared plus 6x plus 9 plus 1. I'm going to distribute that negative 4, so I've got 1 minus 4x squared minus 24x. That's 10, so I'm just going to go ahead and save some time, minus 40, which gives me negative 4x squared minus 24x minus 39. If I wanted to factor out a negative 1, I could. Talk to me, gentlemen. Yes, sir, my brother. Thank you. How did I get 40? Thank you. I just skipped a step. I'm sorry. What's 9 plus 1? 10 times negative 4? Negative 40. I just skipped a step. Negative 4 times 9 is negative 36. Negative 4 times 1 is negative 4. Negative 36 minus 4 is negative 40. You with me, my man? You promise? Oh, wow. Wow. Epic fail for Mr. Morrow. Mr. Morrow should pay attention. You are a beast. Let's do this the right way then. 1 plus negative 4 times x squared plus 6x plus 9. Wow, that was an epic fail for me. No excuse. I should pay attention. You are a beast. Thank you, son. So this is 1 minus 4x squared minus 24x minus 36 plus 1. Wow, I feel like a loser. Sorry, man. So this is negative 4x squared minus 24x, and 2 minus 36 is negative 34. Again, I apologize. Everyone out in the video world, I apologize. You can thank my student for catching me on my mistake. This negative 4 distributes to this, not to the 1. Great job, son. Thank you. Yes, sir. There's no equation here because there's not an equal sign. And if I wanted to simplify, I could factor out a negative 2 if I wanted to. Yes, if I wanted to factor out a negative 2 here, I could, and it'd be x squared plus 12x plus 17. But it's not necessary. 2x squared, yeah. Yes, sir. Yes, sir. Yeah, you could. Okay, you could factor out a negative 1, but you can factor it, but you can't solve, guys. You can't solve unless they're an equal sign. These are just expressions. You can't solve unless they're an equal sign. Thank you so much. Good question. Now, if I wanted to factor this, sure, I could factor, if it's possible. But I'm not looking for that. Thank you, my brother. Anything else, gentlemen? Great questions. Great questions. And again, I apologize. That was my bad. And one more. Okay. So tickets to a concert are available online for $35 each, plus a handling fee of $250. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. So what would the function rule be here? Good man. plus 250. Very good, my brother. So now I want to find the value for 4 tickets. So I'm looking for f of 4. What am I replacing the x with? So 35 times 4. So that's 140 plus 250. So the value of 4 tickets is 142.50. What's my ordered pair here? 4 and 142.50. Very, very, very good. Very proud of you. Good job. Number 8. You are buying bottles of sport drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase? So I have f of x equals 119x. Very good. I want to find the value of this function for 15 bottles of sports drink. So this is 1.19 times 15. And in this case, 17.85. Very good. So the value of 15 bottles of this function is 17.85. What's my ordered pair here? 15, comma, 17.85. Hopefully you guys are seeing, you've done this already before, haven't you? But it's just we use y instead of f of x. Does that make sense? And last but not least, don't get scared of a lot of words. In 2002, the Prestige oil tanker sank and started leaking oil off the coast of Spain. You remember this? When this happened? This really happened. The oil slick took a shape of a circle. Suppose that the area A in square miles of the circle contaminated with the oil can be determined by using the function A of t equals 0.25 pi t squared. Let's look at that. This is function A representing area, where t is the independent variable, where t represents the number of days since the tanker sprang the leak. Identify the dependent and independent variables here. So what's the dependent here, and what's the independent? Very good. Dependent is the area, and the independent is the number of days. The longer period that it kept leaking, the larger the area. Does that make sense? And then B, this is where calculators are great. I want to find A of 30. What am I replacing T with? 30. I'm saying how much of an area are we going to have, how large of an area after 30 days. So we've got 0.25 times pi times 30 squared. This is what you would put a calculator in. Okay, this is where calculators are good. 900 times 0.25 times pi, or 3.14, gives me 7, an area. So after 30 days, my area is 706.5 square miles. That's sad. There's a lot of death there. A lot of animal life, coral reef. Does that make sense? Yes, sir, my brother. No, you would put 3.14. Or plug in the pi value in your calculator, sir. Thank you. What's the order pair here, my brothers? 30 days, 706.5 square miles. Fantabulous. Does that make sense? Any questions at all, my brothers? Going once, twice, sold for $1. Thank you very much. I hope you learned a lot, and have a wonderful day, y'all.